Dubai is waging a war against reality, and if it loses, the city disappears. Over 3 million people live there, a shimmering metropolis built on a foundation of absolute ambition in one of the most water-scarce places on the planet. For decades, they have survived not on rivers, not on rain, but on sheer technological force. They manufacture their water, every last drop, a colossal, energy-hungry system designed to turn an unlivable desert into a global hub. But that system is now showing cracks. The very solutions that made Dubai possible are creating a new, more insidious crisis. The heat is getting more extreme, the sea they drink from is changing, and the weather they are attempting to engineer is turning against them. We're about to break down exactly how they do it and why the entire magnificent experiment might be backfiring. Before we do, what's the one word that comes to mind when you hear man-made rain? Drop it in the comments below, we're curious what you think. Alright, let's begin. And a quick heads up, we go deep on stories like this every week, stories about the intricate systems that run our world, and the fractures appearing within them. A huge number of people who watch and find value in these documentaries aren't subscribed. If that's you, take 1 second to find and hit that button. It's the single most important thing you can do to ensure this kind of deep dive analysis continues. It's urgent for us, and it means we can keep making this for you. Dubai was never meant to be. Before the glass towers and the 8-lane highways, this corner of the Arabian Peninsula was a sparse collection of coastal settlements. Life was governed by two things, the heat and the sea. Summer temperatures made the land itself hostile. Survival depended on trade, on pearling, on a deep understanding of a world defined by scarcity. Water was not a utility. It was life, drawn from brackish wells, guarded jealously, and never, ever wasted. The idea of a city of millions, with lush green golf courses and sprawling private swimming pools, was not just improbable, it was inconceivable, a fantasy. Then came the oil. The discovery didn't just bring wealth, it brought power, the power to defy the environment. The United Arab Emirates, formed in 1971, set out on one of the most audacious nation-building projects in human history. They decided that the desert was not a limit, it was a blank canvas. The population exploded. Foreign workers, financiers, and tourists poured in. The city grew outwards and upwards, a vertical forest of steel and glass rising from the sand. By the 2000s, Dubai had become a global symbol. Luxury, ambition, a future you could visit. And all of it, every hotel, every fountain, every blade of grass, was built on a single fragile resource that the nation simply did not have: water. The UAE has one of the highest per capita water consumption rates in the world, while having virtually no naturally renewable freshwater sources. That is not a problem, it is a paradox, one that requires a solution of almost unimaginable scale, and they built it. The answer lies just off the coast, in a series of sprawling industrial complexes that are the true heart of the nation. Desalination plants. These are not just facilities. They are mechanical gods performing an act of modern alchemy 24 hours a day. The largest of these, the Jebel Ali plant, is a city unto itself, a labyrinth of pipes, turbines, and membranes. Its purpose is simple and monumentally difficult: to take the hypersaline water of the Persian Gulf and strip the salt out, turning it into fresh water pure enough to drink. The primary technology at work is called reverse osmosis. Think of it as a filter, but on a molecular level. Seawater is forced at immense pressures against a series of polymer membranes, so fine that water molecules can pass through, but the larger salt, mineral, and impurity molecules cannot. What comes out one side is pure H2O. What is left behind is the problem. This process is staggeringly energy intensive. It takes a tremendous amount of power to generate the pressure needed. In the UAE, that power comes almost exclusively from burning fossil fuels, natural gas, and oil. The country is effectively burning its geological wealth to create its hydrological lifeblood. Roughly a quarter of all the energy produced in Dubai is dedicated solely to the creation of water. It is a closed loop of consumption. The scale is difficult to comprehend. The Taweelah plant in Abu Dhabi, one of the newest and largest in the world, can produce 200 million gallons of fresh water every single day. 200 million. That's enough to fill over 300 Olympic-sized swimming pools every single day. This is not a supplement to their water supply. It is the supply. Over 90% of all the drinking water in the Emirates is manufactured this way. So you have this colossal machine, a city's metal heart, pumping life from a dying sea. But here's where the numbers get uncomfortable. Let us know in the comments. Do you think engineering can solve any problem? Or are there limits nature will always impose? The entire system depends on the assumption that the source, the Persian Gulf itself, is stable and limitless. It is not. It never was. For every gallon of fresh water produced by desalination, nearly 2 gallons of something else is created, a toxic, super-concentrated sludge known as brine. This isn't just salty water, it's a chemical cocktail. The seawater is treated with chlorine to prevent buildup on the intake pipes and anti-scalants to protect the expensive membranes. These chemicals, along with a concentration of salt more than twice that of normal seawater, are then pumped directly back into the Persian Gulf. Day after day, for decades, the effect has been slow, cumulative, and disastrous. The Persian Gulf is a relatively shallow and enclosed body of water. It doesn't have the deep circulating currents of an open ocean. The flushing time, the time it takes for its water to be replaced, is measured in years. So this brine discharge doesn't just dissipate, it accumulates. Marine scientists have been raising the alarm for years. The data is unambiguous. The salinity of the Gulf is steadily rising, creating conditions that are hostile to native marine life. The brine, being denser than the surrounding water, sinks to the seafloor, smothering seagrass meadows and coral reefs. These are the foundations of the entire marine ecosystem, the nurseries for fish stocks that have sustained the region for centuries. They are being systematically sterilized. The temperature of the discharge water is also several degrees warmer than the ambient sea temperature, creating thermal pollution that further stresses the ecosystem and contributes to coral bleaching. What was once a vibrant sea is slowly, quietly being turned into a barren, overheated saline desert. The very source of the UAE's water is being poisoned by the process of making it. It is a devastating feedback loop, and it gets worse. As the Gulf becomes saltier and warmer, the desalination process itself becomes less efficient. The membranes have to work harder, requiring more pressure, which in turn requires more energy. More energy means burning more fossil fuels, which accelerates climate change, which raises regional temperatures, which increases the demand for water. It is a perfect, self-propelling cycle of unsustainability. The engineers designed a solution for a water problem. They did not design a solution for the laws of thermodynamics. They were not asked to. They were asked to make the desert bloom, and they did, but the sea is now paying the price. And that is a debt that will eventually come due. It's a devastating paradox. Life for the city means death for the sea that surrounds it. If you're getting value from this deep dive, take a second to hit the like button. And if you have family or friends who need to understand the true cost of these futuristic cities, share this with them. It's a conversation we all need to be having. The engineers and officials in the UAE are not blind to this. They are acutely aware that their colossal desalination machine has a fatal flaw, so they turn their attention from the sea to the sky. They decided that if they could not rely on the water beneath them, they would create water from the air above them. This is the science of cloud seeding. It sounds like science fiction, but in the UAE, it is state policy. The UAE's National Center of Meteorology runs one of the most active and ambitious weather modification programs on Earth. The mission is simple: force rain to fall from clouds that would otherwise produce none. The process is both sophisticated and surprisingly direct. A fleet of specialized aircraft loaded with hygroscopic salt flares patrols the skies hunting for specific types of convective clouds that show potential. When a promising cloud is identified, the planes fly into its updraft and fire the flares. The salt particles act as cloud condensation nuclei. In simple terms, they are microscopic decoys that attract tiny airborne water droplets. These droplets, which are too small and light to fall on their own, begin to cluster around the salt particles. They merge, growing larger and heavier until they reach a critical mass. And then they fall as rain, forcing it. The program has been heralded as a major success. The NCM claims its operations can enhance rainfall by up to 25%. Videos regularly circulate online showing manufactured downpours in the middle of a sun-baked desert. On the surface, it is a triumph of ingenuity, a second, seemingly cleaner solution to the nation's existential water problem. Water from the sky, with no brine, no fossil fuels. A perfect answer. But there is no perfect answer. The first issue is scale. The amount of water generated by cloud seeding, while measurable, is a tiny fraction of the nation's overall demand. It is a supplement, a helpful boost. It cannot replace the industrial output of the desalination plants. You cannot run a city of 3 million people on coerced clouds. It is a psychological victory more than a hydrological one. But the more troubling questions are about control and consequence. And I know I've asked once, but if you're still with us and finding this valuable, that subscribe button is just sitting there. I'm told it's a matter of life and death for the channel. Okay, maybe not that dramatic, but it genuinely is the most critical thing for us. Now, back to the sky. In April of 2024, the illusion of control was shattered. Over a 24-hour period, the UAE was hit by the heaviest rainfall ever recorded in its history. A full year's worth of rain fell in a single day. The city of Dubai, a marvel of modern engineering, seized up. The airport, the world's busiest for international travel, became a lake. Runways were flooded, grounding hundreds of flights. The 8-lane superhighways became impassable rivers. Luxury cars were abandoned, submerged in water. Malls, homes, and the city's metro system were inundated. The futuristic city was paralyzed by the one thing it desperately wanted more of: water. Immediately, the questions began. The NCM confirmed that seeding planes had been in operation over the country in the days leading up to the storm. Did they cause this? Officials strenuously denied it. They stated, correctly, that the storm system was a large, naturally occurring weather event forecast well in advance. Cloud seeding, they argued, could not create a storm of this magnitude. It can only enhance what is already there. Most atmospheric scientists agree. Attributing a single weather event to climate modification is notoriously difficult, but that scientific nuance was lost in the floodwaters. The event exposed a deeper, more profound vulnerability. The city was built to keep the desert out. It was not built to handle a deluge from the sky. Its drainage infrastructure, designed for rare desert cloudbursts, was completely overwhelmed. The focus had always been on acquiring water, not on getting rid of it. Whether the cloud seeding program directly caused the flood is almost beside the point. The event revealed the staggering danger of playing with complex systems you do not fully understand. What if they had seeded that specific storm system as it approached? Could a small enhancement have pushed a large system past a critical tipping point, resulting in a wildly disproportionate outcome? Scientists call this nonlinear feedback. The uncomfortable truth is, nobody knows for sure. They asked for rain. They got a catastrophe, a warning shot from an atmosphere that does not respond to demands, only to physics. The crisis in the UAE is no longer just about scarcity, it is now about extremity. The region is a global hotspot for climate change. Temperatures are rising faster than the global average. The number of days exceeding 50 degrees Celsius, or 122 degrees Fahrenheit, is increasing. This extreme heat is not just a matter of discomfort. It is a direct threat to the entire system. Hotter air holds more moisture, making extreme rainfall events like the April flood more likely. Hotter sea temperatures provide more fuel for storms. At the same time, the extreme land temperature increases the demand for water for cooling and basic survival. The desalination plants, already running at their limit, must work even harder, consuming even more energy. The heat is an accelerant, a multiplier for every existing problem. All right, third time's the charm, I know. But we're about to get to the most unsettling part of this entire story, and if you've made it this far, you are exactly the kind of curious person we make these videos for. If you haven't subscribed yet, please consider it. You're our core audience. Now let's talk about the final unbreakable limit. The UAE's water crisis is not happening in a vacuum. It is unfolding in one of the most geopolitically sensitive waterways in the world: Iran, Qatar, Saudi Arabia, Bahrain. Every nation bordering the Persian Gulf is facing its own water crisis, and every one of them is turning to the same solution: desalination. Hundreds of plants now line the coast of the Gulf, all drawing from the same body of water and all discharging their brine back into it. It is a tragedy of the commons on a basin-wide scale, a collective, undeclared war on a shared resource. There is no overarching treaty governing brine discharge, no regional authority managing the cumulative impact. Each nation is acting in its own self-interest, hoping that its engineering is superior, that its economy can bear the rising cost. This creates a new, terrifying possibility: a tipping point. Is there a salinity level at which the Gulf becomes so toxic, so lifeless, that it is no longer usable for desalination? Could the water become so corrosive that it makes the technology prohibitively expensive or even inoperable? Could the marine die-off become so total that the sea itself becomes a dead zone? Scientists call this the brine feedback loop, and it's no longer theoretical. Models suggest that the Gulf's salinity and temperature are on a trajectory to reach levels that will severely impair the very technology that relies on it. To save themselves from the desert, the Gulf nations are creating one in the sea, and at some point the two may meet. The UAE is not a cautionary tale, not yet. It is a live experiment, a city that stared into the abyss of environmental limits and dared to engineer its way out. The scale of their achievement is undeniable. The desalination plants are marvels. The conservation efforts, which include advanced water recycling and drip irrigation, are world-class. The ambition is breathtaking. They have built a future in a place where no future was supposed to be, but their solutions are now breeding their own monsters. The brine is poisoning the sea. The manufactured rain risks catastrophic floods. The reliance on fossil fuels to power it all is contributing to the very heat that makes the entire system so necessary. Dubai is not an anomaly. It is a forerunner. It's the most extreme version of a question facing cities all over the world. Phoenix, Cape Town, Mexico City. How do we sustain growth in a world of shrinking resources? The UAE's answer has been technology at any cost. But the real cost is only now becoming clear. The engineering bought them time to build a global hub, time to diversify their economy away from oil, time for the rest of the world to watch and wonder. The question that remains is not whether they can keep the water flowing. The question is what they will have to sacrifice to do so. A living sea, a stable climate, a predictable world. The city of the future is here, but its foundation is resting on a rapidly dissolving present. The engineering is extraordinary, but the desert has a way of having the final say.